There may be no such thing as what happened, not what happened to you, or to someone else, or to no one at all. What happened, the single settled fact that everyone would agree on, if only they could stand in the right place and see clearly. For most of human history, this was never in question. The world was one world. People disagreed about it because they stood at different angles, or because memory failed them, or because they lied. But beneath the disagreement, there was always assumed to be a fact. One fact, and the whole labor of honesty was the labor of finding it. Quantum mechanics has begun to suggest that this assumption may be false. Two people leave the same dinner and remember the same evening differently. One recalls warmth, the other recalls an insult. We know what to do with this. We assume that one of them is closer to the truth, that there was an evening, fixed and finished, and that the disagreement is a failure of witnesses, not a feature of the world. The evening happened. The only question is who saw it straight. But the theory that governs matter at its smallest scale does not grant us even this. It is the most precisely tested theory in the history of science. In places, it is accurate to 12 decimal places. It is the ground beneath every transistor, every laser, every image a hospital makes of the inside of a living body. And when this theory is pushed to its own edge, when it is asked to describe not a particle, but an observer who is watching a particle, it stops returning a single answer. It begins to forbid the one thing no one ever thought to doubt. It begins to forbid a shared world. This is not a claim from the margins. It was not invented by someone selling a book. It came from inside the mathematics, slowly, across 90 years. And it reached a kind of crisis in the last decade, when two physicists in Zurich proved a theorem that made the problem impossible to set down. The weight of it shows in something ordinary, a coin on a table, face up, heads. The fact that it is heads does not depend on anyone. Someone leaves the room. Someone else walks in. They see heads too. The coin has a property, and the property is simply there, whether or not it is watched. This is so obvious, it feels foolish to say aloud. It is the floor beneath all knowing. The world has properties. We find them. We do not make them. In the quantum world, this floor is not there. A particle, before it is measured, has no definite position, no definite spin. It is described by a single mathematical object, the wave function, that holds all of its possible values at once, each one weighted, none of them yet real. And when a measurement is made, one value appears. The rest vanish. Where they go, no one can say. Why this value and not another, no one can say. This is the measurement problem, and it has sat unsolved at the center of physics since the 1920s. The equation predicts everything it is asked to predict. It says nothing at all about what it is describing. That is the gap. It has never closed. For a long time, the strangeness was kept at a safe distance. The particle was small, the observer was large, the instrument, the laboratory, the human being, all of it lived in the familiar world of definite facts, and only the particle lived in the cloud. The cloud collapsed when it met the world of the large. That was the unspoken arrangement, never quite written down, and it let physicists do their work without losing their footing. In 1961, a physicist named Eugene Wigner broke the arrangement with a single thought. Wigner had helped build the atomic age. He would receive the Nobel Prize for his work on the structure of the nucleus. And in a quiet essay on the relationship between mind and matter, he asked a question that should not have been allowed to be asked. What if the observer is also made of atoms? A sealed laboratory. Inside it, a friend. The friend has a particle and a measuring device, and the friend makes a measurement. The particle was in a cloud of two possibilities: spin up, spin down. Now the friend sees one of them. For the friend, the cloud has collapsed. There is a fact. The friend writes it down. Spin up. But the laboratory is sealed. And from outside it, Wigner describes the whole laboratory. The friend, the particle, the device, the note now resting in the friend's hand, using quantum theory. He has no choice. The friend is made of atoms, and quantum theory is the theory of atoms. And the theory, applied to the sealed room, does not say the friend saw spin up. It does not say the friend saw spin down. It says the friend is in a cloud of both, a superposition of a person who saw one thing and a person who saw the other, held together, unresolved. So there is a fact inside the room, and no fact outside it. The friend knows what happened. Wigner's mathematics says that nothing has, or rather, that both things have, suspended, waiting at the threshold of the sealed door. Both are using the same theory. Neither has made a mistake. And they disagree, not about the value of a result, but about whether a result has occurred at all. There is something familiar in the friend's position. The friend is certain of what was seen, the way each of us is certain of our own afternoon, our own grief, the room we are sitting in right now. And that certainty, seen from the outside, is exactly what the mathematics dissolves. This is Wigner's friend. For decades it was treated as a curiosity, a puzzle for late nights, a thing one could acknowledge and then set down, because no one could make the disagreement do anything. It was a difference of description, not a difference that bit. Then it began to bite. In 2018, two physicists at the Swiss Federal Institute of Technology in Zurich, Daniela Fraukiger and Renato Renner, published a paper whose title reads like a quiet alarm. Quantum theory cannot consistently describe the use of itself. They took Wigner's sealed room and set it inside another. Two friends, two sealed labs, two outside observers, each one reasoning with flawless logic, each one applying the theory exactly as it is written. And they proved that under three assumptions almost every physicist would want to keep, the observers arrive at a flat contradiction. One of them concludes the answer is yes, another concludes the answer is no, and both conclusions follow, with certainty, from the same theory and the same facts. The three assumptions are simple to name. The first, that the theory applies to everything, observers included, with no hidden line where it quietly stops. The second, that if one observer is certain of a result, another cannot be certain of the opposite. The third, that every measurement has one outcome, and not many. You cannot keep all three. This is not an interpretation. It is a proof. Something everyone believed is false, and the mathematics will not say which. For 60 years, Wigner's friend had been a difference one could file away. Now it was a contradiction, and no amount of care could file it. A year later, in 2019, a group led by Massimiliano Proietti in Edinburgh built a version of the experiment out of 6 photons. They made 2 small systems that could each stand in for an observer making a measurement, and they showed that the results break a limit that any theory of observer-independent facts would have to respect. The structure failed, not in principle only, in a laboratory, on a table, in light. Here, the voice must slow, because the popular telling overstates what was done, and the overstatement is the whole thing to avoid. The observers in that experiment were not people. They were not conscious. They were photons standing in for observers, the smallest possible witnesses. And whether a photon is an observer in the sense Wigner meant is one of the open questions, not a settled point. The experiment did not show that 2 human beings can live in incompatible worlds. It showed that the structure which would let any observers share a single set of facts fails already, at the level of light, where the test is cleanest. The terror lives in the structure. The structure does not need a mind to break. And this is the place to set down, plainly, the thing that would otherwise grow like a weed through everything that follows. It is often said that quantum mechanics proves the observer creates reality, that consciousness collapses the wave, that the mind calls the world into being, that attention itself makes things real. It is the most popular thing anyone says about quantum physics. In the form it is usually said, it is false. The real claim is stranger and colder. Nothing in any of these results requires a mind. The observer that fractures the shared world can be a single particle of light. What fails is not the rule of consciousness over matter. What fails is the belief that there is one matter, one world, one settled set of facts, lying beneath all observers alike. The mind is not the hero of this story. The mind may not even be in it, and the loss is larger for that, because if even photons cannot agree on what happened, then the thing that has gone missing is not certainty. The thing that has gone missing is the world we all believed we were sharing. This question is older than the experiment. It is older than the theory. It is older than physics itself. Long before there was a wave function, there were people who sat in silence for years and arrived, by a completely different road, at a conclusion with the same shape, that there is no single fixed reality standing behind appearances, independent of the standpoint from which it is met, that what a thing is cannot be cut away from the relation in which it is found. They had no photons and no theorems. They had attention and time, and a refusal to be comforted by the easy answer. And on several continents, across more than 1,000 years, in languages that never once touched, they wrote down something that the physics of the last decade has only begun, in its own strange vocabulary, to circle. Some of them paid for saying it. Some of what they wrote was buried, or softened, or read for centuries as the opposite of what it meant. The languages are different. The methods could not be more different. The shape is the same. They will be named in time. The figures, the texts, the centuries. For now, they wait at the edge of the room, the way the friend waits inside the sealed lab, present, certain of something, not yet heard. The story of how this question entered physics is a long one. It is the story of how a theory, built to explain the color of heated metal and the steadiness of the atom, came, one measurement at a time, to stand at the lip of a far older depth. It begins with a smaller problem. It begins with the question no one could ever answer about where, exactly, the cloud becomes the coin, where the many become the one, and whether there was ever, anywhere, a single place where that was truly happening at all. The question did not begin as a question about observers. It began as a question about heat. In the last weeks of 1900, in Berlin, a careful and deeply conservative physicist named Max Planck was working on a small and stubborn problem that had nothing to do with minds or measurement or the nature of reality. He was trying to explain the color of a glowing thing, a piece of iron in a furnace, heated until it shifts from red to orange to a faint blue-white. The way the color changes with the heat follows a precise curve, and that curve was a scandal, because the physics of the 19th century, the physics Planck had spent his life defending, predicted the wrong answer. Worse than the wrong answer, it predicted that a warm object should pour out an infinite amount of light at the short wavelength end of the spectrum. The prediction was not slightly off. It was catastrophic. The equation said every warm thing in the universe should be blazing with infinite ultraviolet, and the world plainly was not. Planck found a fix. He did not like it. He found that the curve came out exactly right if he assumed the glowing object could only emit its light in discrete amounts, in packets, in lumps, never in a smooth, continuous flow. Each packet carried an amount of energy tied to its frequency by a single new constant, a very small number that now bears his name. The light did not come in a stream. It came in grains, and with that one assumption, the impossible curve became the measured one, to as many decimal places as anyone could check. Planck thought he had performed a mathematical trick, a bookkeeping device to be cleaned away once someone understood the real mechanism underneath. He called it, years later, an act of desperation. He spent much of the next decade trying to make the grains go away, to dissolve them back into the smooth classical world he trusted. He never could. The grains were real. Nature was not continuous at the bottom. It came in pieces, and no one had asked it to. This was the first crack in the floor. It would not be the last. The grain of light explained the furnace. It did not explain the atom, and the atom by then was its own scandal. Because in 1911, in Manchester, Ernest Rutherford had fired particles at a thin sheet of gold and discovered that the atom is almost entirely empty space, with a tiny dense nucleus at the center and electrons somewhere outside it. A small solar system, and a small solar system made of charges could not exist. The laws of electromagnetism were absolutely clear on this point. An electron circling a nucleus is an accelerating charge, and an accelerating charge radiates away its energy, continuously, and an electron radiating away its energy would spiral into the nucleus in less than a billionth of a second. Every atom in your body should have collapsed before it finished forming. Matter should not be here. In 1913, a young Dane named Niels Bohr fixed the atom by forbidding it to behave. He simply declared that the electron was allowed to occupy only certain special orbits, and in those orbits it did not radiate, and it could jump between them by emitting or swallowing a single grain of Planck's light, exactly the right size to cover the gap. There was no mechanism, there was no why, there was only the rule, and the rule worked. It predicted the precise pattern of light that hydrogen gives off, the exact ladder of colors, with an accuracy that silenced the objection that it made no sense. The atom was stable because nature said it was, in steps, with nothing allowed in between. The discreteness had reached the foundation of matter itself, and again, no one had chosen it. It was extracted from the world under protest. So the century opened with a world that had quietly stopped being smooth, light in grains, matter in steps. The continuous fabric that physics had taken for granted for 200 years was gone, and what replaced it was a set of rules that worked perfectly and explained nothing. For a while, this could be tolerated. The rules were patchwork, provisional, waiting for the real theory underneath. The real theory arrived in the winter of 1926, and it made everything stranger. It came from Erwin Schrödinger, an Austrian physicist who worked out the central equation of the new physics during a single winter holiday in the Swiss Alps, in a burst of concentrated work that produced, in a few months, the mathematics that would govern the next 100 years. His equation does something very specific. It takes a quantum system, an electron, an atom, anything, and it describes that system not as a thing with a position, but as a wave, a spread-out mathematical object that fills space, that has a value everywhere, that flows and ripples and evolves in time, with the smooth inevitability of a wave moving across water. This object is the wave function. It is the cloud that the listener has already met, and Schrödinger's equation tells you, with total precision and total determinism, how that cloud will move. Feed in the cloud now, and the equation hands you the cloud at any moment in the future. Nothing is left to chance. The evolution is exact. Schrödinger believed, at first, that the wave was real, an actual physical ripple, the electron smeared out into a wave of matter. It was a beautiful idea, and it was wrong, and the man who showed it was wrong was a colleague in Göttingen named Max Born. Born looked at the wave and asked a simple question. When you actually find the electron, when you put down a screen and the electron strikes it at a single point, as it always does, where is the wave then? And his answer changed the meaning of everything. The wave, Born said, is not made of matter. The wave is made of probability. Its height at any place does not tell you how much electron is there. It tells you how likely you are to find the whole electron there, if you look. The cloud is not a smeared-out thing. It is a map of chances. This is the move that Einstein could never forgive, because Born's rule put randomness into the foundation of the world, and not the ordinary randomness of a coin or a die, where the outcome is fixed and we are merely ignorant of it. This was randomness with nothing underneath. The wave function contains everything there is to know about the electron. It is the complete description, the theory insists, and even so, it does not determine where the electron will land. It gives only the odds. Einstein wrote to Born that God does not play dice with the universe. Born's probabilities, he was certain, were a sign that the theory was unfinished, that some deeper layer of fixed facts lay beneath. The argument between them lasted the rest of their lives. The experiments, in the end, did not side with Einstein. And here, almost unnoticed, the deepest problem in all of physics quietly opened. Because there are now two rules, and they do not agree. When no one is looking, the wave function obeys Schrödinger. It flows smoothly, deterministically, spreading and rippling, every possibility alive at once. And when someone looks, the wave function obeys Born. It jumps, instantly and randomly, to a single value, and all the other possibilities vanish without a trace. Two laws, one smooth and certain, one sharp and random, and nothing in the theory says where the first law ends and the second begins. Nothing says what counts as looking. Nothing says what a measurement is. This is the measurement problem. It is the gap between the cloud and the coin, the place where the many become the one, and from the moment it opened, no one could say where, exactly, that place was, or what happened there, or why. The men who built the theory knew the gap was there. Their response was to draw a line and refuse to look past it. The line came from Bohr, in Copenhagen, working with the young and brilliant Werner Heisenberg through the late 1920s, and the way of thinking they produced has governed the practice of physics ever since. Heisenberg had already shown, in 1927, that you cannot pin down both the position and the motion of a particle at once, not because your instruments are clumsy, but because the particle does not possess both at once. The sharper its position, the more its motion dissolves into indefiniteness, and the reverse, locked together by Planck's constant in a trade that cannot be escaped. This was not a limit on knowledge. It was a limit on being. The particle simply does not have the properties we assume until something forces them into focus. Bohr built a whole philosophy on this refusal. He said that it is meaningless to speak of what a quantum system is doing when no one is measuring it. The wave function is not a picture of reality between measurements. It is a tool for predicting what the next measurement will show. The world divides into two domains: the quantum system, described by the cloud, and the classical apparatus that measures it, described by ordinary definite facts, and a line runs between them, the cut, on one side of which things are indefinite, and on the other side of which things are definite. Where is the cut? Bohr's answer was as subtle as it was evasive. The cut can be placed anywhere you like. You can draw it just outside the electron, or further out past the detector, or further still past the laboratory wall, and the predictions come out the same wherever you draw it. The position of the line does not matter, as long as there is a line. The cut is movable, the cut is necessary, and the cut is never, ever located. This is the arrangement that let physics work for 100 years. It is sometimes summarized, with a shrug, as the instruction to stop asking what it means and simply calculate. The phrase is a little unfair to Bohr, who thought about the meaning more deeply than almost anyone. But the shrug captures something true. Copenhagen is a recipe. It tells you, with flawless accuracy, what you will see when you look. It does not tell you what is there when you do not. It does not tell you what looking is, or why it is special, or what happens in the gap. It draws a line around the mystery and declares the inside of the line off limits. And for generations of working physicists, that was enough, because the recipe never failed, and the inside of the line never had to be entered to build a laser or split an atom or send a current through a wire. The mystery was real. It was simply walled off. Most people learned not to look at the wall. One man looked at the wall and proved that it could be moved anywhere, and that wherever it went, it had nowhere to finally rest. He was John von Neumann, a Hungarian whose mind worked with a speed that frightened the people around him, a mathematician who could hold the entire structure of the new physics in his head and set it down with total rigor. In 1932, he did exactly that. He gave quantum mechanics its precise mathematical form, the form still taught today, states as vectors in an abstract space, measurements as operations upon them, and within that form, he isolated the measurement problem with a clarity no one had managed before. He showed that the theory contains two distinct processes. One is the smooth Schrödinger flow, deterministic and continuous, which he called the second process. The other is the sudden collapse to a single outcome, random and discontinuous, which he called the first. And then he did the thing that made the gap impossible to wall off cleanly. He took the measuring device itself and described it with quantum mechanics, because the apparatus is also made of atoms. The detector, the pointer, the dial, all of it is matter, and matter obeys the Schrödinger equation. So von Neumann modeled the measurement honestly. The electron, in its cloud of possibilities, interacts with the detector, and the detector does not collapse the cloud, it joins it. The pointer enters a superposition of pointing here and pointing there, entangled with the electron, both possibilities alive together. And you can include the next device that reads the first one, and it too enters the superposition, and the light traveling from the dial to the eye, and the retina the light falls on, and the nerve carrying the signal inward, and the brain it arrives in. The cloud does not collapse anywhere along this chain. It only grows, swallowing each new piece of apparatus into the superposition, link by link, with no natural place to stop. This is the von Neumann chain, and its lesson is precise and unsettling. The cut, Bohr's line between the indefinite and the definite, can be slid anywhere along the chain, and the predictions never change. You can put it at the detector, or at the retina, or at the brain, and the mathematics does not care. But the chain has one end it cannot pass. It cannot pass beyond the awareness of the observer, because that awareness is the one thing in the whole sequence that is never itself observed by anything further. Everything else can be measured by the next link. The final experience cannot. And so von Neumann, and after him others, were forced to notice that the only place the chain naturally terminates is at the threshold of consciousness itself, the one point where the regress of measurement has nowhere left to go. He did not claim that the mind reaches in and collapses the wave. He showed something more careful and more troubling, that the mathematics permits the line to be drawn there, at the edge of awareness, and gives no reason to draw it anywhere else. He left the door standing open. It was only a matter of time before someone walked through it. For now, the problem could still be held at arm's length, treated as a technicality, a puzzle for the philosophically inclined. The men who had built the theory did not all accept it. Two of them, in the same year, tried to break it. The year was 1935, and it produced the two most famous objections in the history of physics, both designed as weapons, both of which the theory survived. The first came from Schrödinger himself, who had grown disturbed by what his own equation implied. He imagined a cat sealed in a box with a single radioactive atom, a detector, and a vial of poison rigged to shatter if the atom decays. The atom, being a quantum system, exists in a superposition of decayed and not decayed, and the equation, applied honestly, drags the cat into the same superposition, alive and dead at once, both states real, until the box is opened. Schrödinger did not offer this as a wonder. He offered it as an absurdity. He thought it showed that the theory, taken to its logical end, produced nonsense, and that the nonsense proved something had gone wrong. The cat was meant to refute the physics. Instead, the cat became its mascot, repeated for 90 years as a charming illustration of the very thing it was built to destroy. The weapon was mistaken for a toy. The second objection came from Einstein, with two younger colleagues, in a short paper whose title asked whether the quantum description of reality could possibly be complete. Their answer was no. They pointed to a strange feature of the mathematics. Two particles can be linked, entangled, so that measuring one instantly fixes the state of the other, however far apart they have traveled. To Einstein, this was intolerable. Either the measurement here was reaching across the distance to disturb the particle there, which he dismissed as spooky action at a distance, or the particles had carried their properties with them all along, and the wave function's silence about those properties simply proved it was an incomplete account of a deeper, definite reality. He was sure it was the second. He was arguing, once again, for a hidden layer of fixed facts beneath the cloud, and once again, the universe would prove less reasonable than he hoped. But the proof would not come for another 30 years, when a quiet physicist named John Bell found a way to turn Einstein's objection into something an experiment could decide. That is a thread the script will follow to its end. What matters here is only that the great objections of 1935 failed, and that the theory walked through them untouched, carrying its gap intact. The gap remained, and in 1957, a graduate student took the most radical step anyone had taken toward closing it. He closed it by refusing to believe in collapse at all. His name was Hugh Everett. He was working at Princeton under John Wheeler, and his proposal was as simple to state as it was vast to absorb. The second process, he said, the smooth Schrödinger flow, is the only process there is. There is no collapse. There is no first process. The wave function never jumps, never narrows, never chooses. It only evolves, forever, exactly as the equation says. And when a measurement happens, the observer does not see the cloud collapse to one outcome. The observer becomes part of the cloud. The person who measures the electron enters a superposition along with it, a version of the observer who saw spin up, and a version who saw spin down, both equally real, both fully present, each one convinced that a single definite thing has happened. The cat is alive and dead, and there are now two observers, and each sees only one cat. Nothing was lost in the measurement. The world simply branched, and every branch is real, and we ride along one of them without ever feeling the split. It is a theory of breathtaking economy and breathtaking cost. The economy is that it removes the entire measurement problem at a stroke. No special process, no mysterious line, no privileged role for the observer, nothing but the equation doing what the equation does. The cost is an unobservable infinity of branching worlds, splitting at every quantum event, multiplying past all counting, none of them ever able to touch or detect the others. Wheeler admired his student and worried about the cost. He called it, gently, an excess of metaphysical baggage. The name it is known by now, the many worlds interpretation, came later, from another physicist a decade on. Everett himself spoke only of relative states and a single universal wave function that never breaks. When he traveled to Copenhagen in 1959 to defend the idea to Bohr's circle, it went badly. The old guard found it unphysical. Discouraged, Everett left academic physics altogether and spent the rest of his career working on weapons analysis for the Pentagon, his interpretation, almost forgotten, to be revived only after his death. And the deepest objection to his theory was never really answered, and is not answered now. If every outcome happens in some branch, then what can it possibly mean to say that one outcome is more probable than another? The theory keeps the equation pure and pays for it with the very thing the equation was supposed to predict. The question of where probability lives, in a world where everything occurs, remains open. It is one of several places where the escape routes from the measurement problem each turn out to charge a toll. It is a picture worth holding before it is set down. On Everett's account, this instant, the quiet of the room, the breath just taken, is not the only one. It is one branch among uncountable others, splitting away even as it is lived, each version certain it is the whole of what happened. The split is silent. Nothing inside a branch ever feels the branching. There is only the moment, seamless and singular, with no trace of the others it parted from. Whether that is the truth of things, no experiment has ever been able to say. The branches, by their nature, cannot be seen from within. There was another way to keep the gap from swallowing the world. Instead of removing the observer's special role, one could take it absolutely seriously. And the man who did that was the same man who had already, in a single thought, set the sealed room before us. Eugene Wigner took von Neumann's open door and walked through it. He had read the chain, and he had seen where it terminates, and in 1961 he drew the conclusion that von Neumann had only gestured at. If the chain of measurement can be passed link by link through every piece of apparatus, and the one thing it cannot pass is the awareness of a conscious mind, then perhaps that is exactly where collapse happens. Perhaps consciousness is the thing that breaks the superposition. Perhaps when his friend in the sealed laboratory becomes aware of the result, that awareness is what forces the cloud to choose, so that the friend really does have a single definite outcome, even though Wigner's equations, applied from outside, still show a superposition. The friend's mind, on this view, does what no apparatus can. It reaches into the cloud and makes it one. This was not a fringe idea proposed by a crank. It was held, carefully and seriously, by one of the most rigorous physicists of the century. And for a time, it was the most respectable account on offer of what breaks the chain. And here is the part of the story that almost no one tells. Wigner gave it up. Over the years that followed, he came to see where the idea led, and he did not like the destination. For if his consciousness collapses the wave, then what of his friend's consciousness? Does the friend's mind collapse the cloud, or does the friend remain in superposition until Wigner himself becomes aware? The logic slides, almost helplessly, toward a single privileged observer, toward the suspicion that only my consciousness is real, and everyone else hangs in a cloud until I look. Wigner saw this drift toward solipsism, and he was too honest to accept it. And around the same time, a new idea was emerging that offered a way to explain the appearance of collapse without invoking the mind at all. Influenced by that work, Wigner quietly abandoned the view he had become famous for. The most celebrated proponent of the claim that consciousness collapses the wave function was the man who first made it rigorous, and then he set it down, because he followed it far enough to see what it cost. The idea did not die because it was foolish. It died because its own author walked all the way to its edge. The new idea that helped change his mind would, for a generation, look like the answer everyone had been waiting for. It began in 1970, in a paper by a German physicist named Dieter Zeh that almost no one read for a decade, and it was carried forward through the 1980s by Wojciech Zurek at Los Alamos into the form we know today. The idea is called decoherence, and its starting point is a single honest observation. No quantum system is ever truly alone. The electron in the laboratory, the cat in the box, the pointer on the dial, none of them sits in perfect isolation. Each is bathed, constantly, in an ocean of other particles, stray photons, air molecules, the faint thermal trembling of everything around it. And every one of those countless tiny interactions is, in von Neumann's sense, a measurement. Each collision entangles the system a little more with its environment, threading the superposition out into the surrounding world. What this does is subtle, and it is the key to why the world looks the way it does. The strange part of a superposition, the part that lets an electron interfere with itself, the part that makes the quantum world quantum, lives in delicate relationships between the possibilities, relationships that can only be seen if the possibilities are kept together. Decoherence tears them apart. As the superposition leaks into the environment, those delicate relationships are not destroyed, but they are scattered, distributed across so many particles, so many degrees of freedom, that they can no longer be gathered back together by any local means. The interference becomes, for all practical purposes, impossible to recover. And this happens with a speed that defeats imagination. For anything the size of a dust mote, let alone a cat, the relevant interactions complete in a tiny fraction of a second, faster than any measurement could ever catch the object mid-superposition. This is why you have never seen a cat that is both alive and dead. Not because the superposition is forbidden, but because the moment it forms, the world around the cat measures it, instantly, relentlessly, and the strangeness drains away into the environment before any eye could fall on it. The solidity of the table, the simple fact that the room does not shimmer with overlapping possibilities, has a mechanism now, and the mechanism is decoherence. For a long time, this looked like the door finally closing on the measurement problem. It is not the door closing. And the reason why is the most important thing the foundation has to teach. Decoherence explains, with great precision, why the outcomes we see look definite. It explains why the pointer reads cleanly here or cleanly there, and never blurs between them. It explains why the world sorts itself into the stable, classical, well-behaved shapes we wake up to every morning. But it does not explain why there is one outcome rather than another, and it does not explain why there is a single outcome at all. Look closely at what decoherence actually does. It takes the cloud, the system in a genuine superposition, every possibility entangled and alive, and it spreads that superposition into the environment so thoroughly that, to anyone confined to the system, it becomes indistinguishable from an ordinary list of separate possibilities, each with its own probability. It turns something that looks like and into something that looks like or, but it only looks like or. Underneath, in the full description of the system and its vast environment together, every branch is still there. Nothing has been removed. The cat alive and the cat dead are both still present in the total wave function, decohered from each other, no longer able to interfere, but no less real. Decoherence produces the appearance of collapse. It does not produce collapse. The single experienced outcome, the one world the observer actually finds, is exactly what it cannot deliver. So the gap is not closed. It is relocated and made more precise and handed back. The careful physicists who built decoherence theory always knew this. The textbook summaries that imply the problem was solved are saying more than the mathematics permits. Here is the honest position, the one a working physicist will give you in a quiet moment. The equations work. The predictions are confirmed to absurd precision. Decoherence explains the form and the stability of the classical world. And the central question, why the cloud becomes a single coin, why one branch and not the others, what happens in the place where the many become the one, has not been answered. It has been open since 1926. It is open tonight. Anyone who tells you otherwise has stopped looking at the wall, and there is a pressure point in that gap that the foundation has not yet pressed. Every account so far has placed the observer on the outside, looking in, drawing the line somewhere ahead of itself, measuring a world it stands apart from. But the von Neumann chain already whispered the danger. The observer is made of atoms too. The one who measures can always, in principle, be measured. And when that move is finally made in full, when the observer is sealed inside the description and another observer is set to describe them from without, the gap does not merely persist. It begins to do something no one expected. It begins to tear the very idea of a single shared world along a seam that no recipe, no collapse, no branching, and no decoherence had ever quite revealed. That is the seam where the foundation ends, and the depth opens beneath it. Every escape so far has shared one quiet assumption. The observer stands outside. The one who measures is never themselves measured. Collapse, branching, decoherence. Each of them drew the line somewhere ahead of the observer and let the observer look in from a place of safety, a place where facts are simple and the world is one. But the chain already whispered the danger. The observer is made of atoms too, and the one who measures can always, in principle, be measured by something further out. So the question was always there, waiting to be asked in full. What happens when the observer is sealed inside the description? What happens when a second observer is set to watch the first, from without, using the same theory, with the same right? For 60 years this stayed a thought experiment, a puzzle for late nights. And then, in 2018, it stopped being a puzzle and became a proof. Two physicists wrote down the sealed room and nested it inside another sealed room and followed the logic all the way to the end. What they found was not strangeness, it was contradiction. The theory, turned on itself, breaks. This is where the foundation cracks, not at the edges, at the center. The two physicists were Daniela Fraukiger and Renato Renner in Zurich, and the move they made was to let the observers reason about each other. This is the part that matters, and it is worth slowing for. In the ordinary sealed room, there is a friend inside and an observer outside, and they disagree. In the new version, there are two friends, each in their own sealed lab, and two observers outside, each watching one lab. And the observers do not merely measure, they think. Each one applies quantum theory, not only to particles, but to the other agents, to what the friend inside must have seen, to what the other observer must be concluding. Each agent reasons, with perfect logic, about the reasoning of the others. It is a hall of inferences. One agent says, "I know what I measured, and from that I know what she must have seen, and from what she saw, I know what he will conclude." Each link in that chain is licensed by the theory. Each one, taken alone, is sound. And when the whole chain is laid end to end, it closes into a loop that contradicts itself. And there is a particular run of the experiment in which those chains of reasoning collide. One agent concludes, with certainty, that the outcome must be a certain value. Another agent, reasoning just as carefully, using the same theory, concludes with equal certainty that it cannot be that value. Both inferences are valid. Each step follows from the last, and the conclusions cannot both be true. There is no error to find. The contradiction is not a mistake in the calculation. It is in the theory, when the theory is used to describe agents who are themselves using the theory. Schrödinger and Renner showed that you can hold at most 2 of 3 assumptions. The first is that quantum theory applies to everything, agents included, with no hidden boundary where it stops. The second is that the agents are consistent, that if one is certain of a result, another cannot be certain of its opposite. The third is that every measurement has a single outcome. Keep any 2. The third must fall. This is not an interpretation. It is a proof, and it does not tell you which of your certainties was the false one. Here, the honest reader must add something. The force of the theorem depends on what you were already willing to give up. To someone who follows Everett, who already denies that measurements have single outcomes, the result is no shock at all. They surrendered that assumption long ago. But for everyone who wants to keep a single world with single facts, the theorem is a wall. It says, you cannot have all the ordinary things at once. Something you took for granted is not true, and the mathematics will not say which. There is a particular vertigo in that. It is the vertigo of 2 people who were both in the room, both certain of what happened, and the impossibility of saying who was right, except that here, the impossibility is not a failure of memory or evidence. It is written into the law. Let that settle, because it is easy to pass over. In ordinary life, when 2 accounts collide, we believe that patience will resolve them. More evidence, a clearer view, a witness who saw the whole thing. We believe that somewhere there is a fact of the matter, and the only trouble is reaching it. The theorem takes that comfort away. It does not say the witnesses were careless. It says that even with perfect logic, perfect information, and nothing at all hidden, the accounts can refuse to meet. The fact of the matter is, the thing that goes missing, not our grip on it, it. A year later, the sealed room was built, not as a thought, as an apparatus. In 2019, a group in Edinburgh, led by Massimiliano Proietti, took the logic of the sealed room and put it on a laboratory table, out of 6 photons. 2 of those photons were made to play the role of observers, small systems that register a measurement, that hold a definite result inside their own little world. And the experiment compared what those inner observers recorded against what the outer observers measured, and tested whether all of it could fit inside a single, shared, observer-independent set of facts. It could not. The results broke the bound that any such shared world would have to respect. The structure failed, not in principle only, in light, on a table, in a real laboratory, in a real city. And now, the discipline that has run through this whole account must be stated again, because the popular telling drops it, and dropping it changes everything. The observers in that experiment were not people. They were not conscious. They were photons, standing in for observers, the smallest witnesses anyone could build. Whether a single photon is an observer in any meaningful sense is one of the open questions. It is not a settled point, so the experiment did not prove that 2 human beings can live in incompatible worlds. It proved something narrower, and in some ways stranger. The formal structure that would let any observers share one set of facts fails already at the level of light, where the test is cleanest and the claim is purest. The crack is in the architecture. It does not need a mind to show. This is exactly why the careful physicist refuses to overstate it. The experiment confirms the formal result. It does not reach all the way up to conscious observers, and the honest ones say so. The gap between a photon and a person is precisely the gap no one has closed. The smallest systems show the strangeness at its cleanest. The largest ones, the ones that wake and remember and call themselves observers, are exactly where the clean result runs out. No experiment has yet carried it across that distance. Whether it can be carried at all, no one knows. The walls, though, kept closing, because in 2020, a third result arrived, and it was stronger than the first. A group in Brisbane, working around Eric Cavalcanti and Howard Wiseman, proved what they called the local friendliness theorem, and its strength is this. Frauschiger and Renner had to assume that quantum theory is universally correct, true of agents as well as particles. The Brisbane result does not assume that. It does not lean on quantum theory being the final word at all. It is built instead from a few very general principles, that the events an observer actually witnesses are absolute facts, that what happens here is not instantly steered from far away, that an experimenter may freely choose what to measure. From those alone, with no commitment to quantum theory's universal reach, a certain inequality must hold, and in the laboratory, the inequality is violated. So the escape route of doubting quantum theory's reach is closed. You cannot wriggle out by saying the theory simply does not apply to large things. The trap is woven from premises far more basic than the theory itself. One of them must go. The absoluteness of what an observer sees, the plain idea that when someone witnesses an event, that event simply happened, once, for everyone, and not only for them. Or locality, the idea that what occurs here is not secretly arranged from somewhere far away, or the freedom to choose what to measure. These are not technicalities. They are the floor under the idea of an ordinary, shared, public world. And the experiment says one of them is false. 3 results in 3 years, each one tightening the same knot. It is worth pausing here before going further into the dark. Step back from the photons and the theorems for a moment to the plain thing they are circling. Each morning, a person wakes and assumes, without ever once examining it, that the world they open their eyes onto is the same world everyone else opens their eyes onto. One sun, one room, one set of facts, holding still beneath all of us, the same whether seen or unseen. This assumption is so deep it has no name. It is simply what it means for there to be a world at all, and it is precisely this assumption that the 3 results press against. Not the contents of the world, but its singleness. The quiet faith that there is one of it. Not one sun and one room as facts we might be wrong about. Those we could always correct. But one world as the container of all facts, the same for every eye. That is the thing under pressure. Not what is in the world, that there is a single world to be in. So what does the physics actually propose to do with this? The leading answer is also the strangest, and it comes from a physicist who works on the structure of space and time in Marseille, and who has written, elsewhere, about the nature of time itself. His name is Carlo Rovelli, and in 1996, he offered a way to make the contradiction dissolve. The cost is the single shared world. He called it relational quantum mechanics, and its central claim is simple to say and very hard to absorb. There are no absolute facts. There are only facts relative to a system. A property of a particle is not something the particle has on its own. It is something the particle has in relation to another system, the thing it has interacted with, the thing that has, in the broadest sense, measured it. And measurement here has nothing to do with minds. This is the heart of it. Any interaction is a measurement. One particle striking another is a measurement. A photon absorbed by a speck of dust is a measurement. The dust now holds a fact about the photon, relative to the dust. The relation is physical, total, and impersonal. So what is a fact on this picture? A fact is always a fact for something, never a fact in the abstract, hanging free. The warmth of a room is real, to the body that feels it. The reading on a dial is real, to whatever the dial is wired to. None of this is less than real. It is only that the reality has an address. It belongs somewhere. It is held inside a relation, and outside that relation it does not float untethered, waiting to be true for no one. So when the friend inside the sealed room sees a result and Wigner outside still describes a superposition, they are not contradicting each other. They are stating facts relative to different systems. Relative to the friend, the outcome is definite. Relative to Wigner, it is not yet. Both are true. There is no further fact, no master account, no description from outside all relations that says what really happened. There is no view from nowhere. There never was. This is the place where the misreading grows, and it must be cut out cleanly, because it is the exact opposite of what the physics says. It is sometimes claimed that all of this proves reality is subjective, that there are no facts, that one account is as good as another, that science has shown each of us lives in a private truth and may believe what we like. This is false, and it is almost the reverse of the truth. Relational facts are not arbitrary. They are rigidly fixed by physics. The friend cannot see whatever the friend wishes. The photon registers one definite value and not another, with iron necessity, relative to whatever it touched. What dissolves is not the discipline of facts. What dissolves is the single global fact that stands above all systems at once. The world becomes more constrained, not less. A dense web of relations, each one strict, with no soft center where anything goes. Whoever tells you the quantum world means your feelings are facts, has understood neither the quantum world nor facts. There is a second way through, gentler in tone, and it relocates the fact somewhere else entirely. It is called Cubism, and its clearest voice is the physicist Christopher Fuchs, who insists that the wave function was never a picture of the world to begin with. On this view, the wave function lives in the head of the agent. It is a catalog of one agent's expectations, the odds that agent assigns to what they will experience next. And a measurement outcome is not an event in the world. It is an experience the agent has, a personal updating of belief. The world does not contain the click of the detector as a public fact. The agent experiences the click. That experience is the outcome for that agent. Another agent, watching from outside, has not yet had that experience, and so for them, the click has not become anything at all. So the friend and Wigner write down different wave functions, because they are different agents with different information, and there is no contradiction, because the wave function was never about the world. It was always about the agent's expectations of it. It is coherent, and it is, for many, deeply unsatisfying, because it goes quiet exactly where one wants it to speak. Ask Cubism what is out there, between experiences, when no agent is expecting anything, and it declines to say. Critics call it anti-realist, a retreat from the old ambition to describe nature as it is. The Cubist answers that the old ambition may simply have been a mistake. No one has shown which side is right. Notice what the two escapes share. Each one saves consistency by moving the fact out of the world and into a relation, or out of the world and into an agent's experience. Neither lets the fact float free, the same for everyone, anchored to nothing. That anchor is the thing that broke. And once it is gone, it cannot be quietly slipped back into place. every serious attempt to restore it has had to pay for it somewhere else, in worlds, in non-locality, in silence. And the quiet of a room at night, the sense that the world is simply there, holding still around you while you rest, that sense is real as an experience, and silent as a proof. The physics does not say the room is not there. It says there may be no version of the room that belongs to no one. These are not the only doors. They are simply the ones that fit this particular crack. And every door out of the measurement problem charges a toll. This is worth seeing plainly, because the existence of many interpretations is sometimes mistaken for the existence of an answer. It is the opposite. After a century, no interpretation commands consensus, and each survives only by paying a price most physicists are unwilling to pay. The many worlds picture, defended now by careful philosophers like David Wallace and physicists like Sean Carroll, keeps the wave function real and objective, and keeps a single law, and pays with an unobservable infinity of branching worlds, and with a problem it has never solved, the problem of what probability could even mean in a world where every outcome happens. The pilot wave picture, descended from Louis de Broglie and David Bohm, keeps particles with definite positions and keeps strict determinism, and pays with an explicit, permanent non-locality, a guiding wave that reaches across all of space at once, faster than light, forever beneath the surface, where it can never be used or seen. And then there are the theories that change the equation itself. The objective collapse theories, written first by Girardi, Rimini, and Weber, and in Roger Penrose's version, where the weight of gravity is what finally tips a superposition into a single outcome, add a real physical process that genuinely destroys the cloud. No observer is needed, no relation, no agent. The collapse simply happens, on its own, growing more likely the larger the thing becomes. And this class of theory has a property the others lack. It predicts something different from ordinary quantum mechanics, something that could be measured, something that could be wrong. Alone among all the options, it can be put to the test, and it has been. Deep underground, shielded from the noise of the world, physicists have searched for the faint signature the simplest gravitational version would have to leave behind. They did not find it. The simplest form of the idea is now in serious trouble. This is what honesty looks like in this field. A beautiful theory, carried to the bench and told no by the world. There is even a frontier formalism due to Yakir Aharonov, in which the facts of the present are shaped by boundary conditions reaching both forward from the past and backward from the future. Each of these is a serious proposal by serious people. Not one of them is free. So the field holds many maps and no agreed territory. The honest position is the one a working physicist will give you only in a quiet moment. The mathematics works. The predictions are confirmed to a precision with few equals in all of science. And what any of it means, what reality is actually doing when the cloud becomes the one fact, is not known, not unknown because no one has looked, unknown at the foundation. This is not the unknown of a missing measurement, or a number not yet pinned down. Those are filled in with time and patience. This is the other kind, the kind that sits in the structure of the theory and does not move when more data arrives. A century of the most exact experiments ever performed has not touched it. It is not waiting for a better laboratory. It is waiting for an idea no one has yet had. And decoherence does not rescue this, though it is often hoped that it might. Decoherence explains why outcomes look definite to an observer already inside one branch, already on one side of the cut. But the no-go theorems are about exactly the thing decoherence cannot touch. What happens when you compare observers across the cut? When you ask whether their separate definite worlds can be stitched into one? Decoherence always presupposes a perspective. It cannot deliver the perspective-free fact the theorems show is missing. It explains the appearance of the shared world. It cannot restore the shared world itself. There is a quiet that comes at the end of a long line of reasoning, when every escape has been tried and each one has closed. It is not the quiet of an answer. It is the quiet of a question that has been followed all the way down to where it lives. The mind wants resolution, and is offered instead a clear view of exactly what is not known. There is a kind of rest in that, too, the rest of stopping at the true edge, and not a false one. This is where physics arrives, by its own most rigorous road, not at an answer, at a wall, and the wall is load-bearing. The measurement problem opened in 1926, and it is open tonight, and these three results have not closed it. They have done something subtler and harder. They have sharpened it to a single edge. The thing that fails is not our knowledge of the world. It is the assumption that the world is one, that beneath every observer there lies a single set of facts, holding still, the same from every side, belonging to no one and binding on all. What the most careful physics now suggests, without proving, is a reality of a different shape. A reality in which what something is cannot be cleanly cut away from the relation it stands in which the separateness we take for granted, the clean boundary between this system and that one, between the observer and the observed, between my world and yours, may be the surface and not the ground. The parts may not be finally separable. The single fact may not stand alone, and every method physics has, the equations, the theorems, the experiments on the table, points to this shape and then falls silent, because the shape is the limit of what those methods can reach. This is not a defeat. It is a boundary, and a boundary is a real finding. Physics has not failed to answer the question. Physics has discovered that the question has an answer it cannot, with its own instruments, fully reach, that the nature of the single fact, or its absence, lies just past the last thing an equation can say. The wall is not ignorance waiting to be cleared away. The wall is part of the map. It is a strange place for the most precise science ever built to come to rest, a reality whose deepest layer it can describe, and confirm, and measure, and not understand. The question stands open at the edge of the formalism, fully alive and older, somehow, than the mathematics that finally cornered it, as if it had been asked before, as if, long before there were equations, someone had already stood exactly here, at the place where the separate world dissolves, and looked, and not turned away. Someone did stand there, not once, and not in one place. Long before there were equations, there were people who turned their attention not outward onto the world, but inward onto experience itself, and held it there, for years, with a discipline that has no real equivalent in ordinary life. They were not trying to build a theory. They were trying to see what is actually the case, beneath the assumptions that the mind makes too quickly to notice. And several of them, on different continents, in languages that never once touched, reported back something with the same shape as the place physics has just arrived. No thing standing alone. Separateness as the surface, and not the depth. And no view from outside at all. No single fact above the rest. What follows must be handled with great care, because it is so easy to ruin. There is a popular habit of saying that the old contemplatives knew what physics has only now discovered, that the sages saw the quantum world in advance. This is false, and it cheapens both. They were not doing physics. They had no instruments, no measurements, no mathematics of the kind that could be tested. And physics is not doing mysticism. The equations make no mention of the sacred. What is worth attention is narrower than the popular claim, and far stranger. Two utterly different methods of investigation, aimed at two utterly different goals, arrived at a reality built on the same architecture. The languages are different. The methods could not be more different. The structure is the same. That is not proof of anything. It is recognition. Not the recognition of one mind in another, but the recognition a traveler feels on finding, in a country they have never visited, a building raised to the same plan as one back home, by builders who never met, who shared no drawings, who did not know the other country existed. The plan is the thing that is shared, only the plan, and it begins with the man who saw the structure most precisely and refused, to the end, to soften it. 2,000 years ago, in the south of India, a monk named Nagarjuna did something that has unsettled philosophy ever since. He took every possible position about the nature of reality, that things exist, that they do not exist, that they both do and do not, that they neither do nor do not, and he dismantled all four. This is the heart of the school he founded, the school of the middle way, and the text where it lives is called the Fundamental Verses on the Middle Way. What was left when he finished was not nothing. It was something he refused to name. The thing he was dismantling was a single hidden assumption, the assumption that things have their own being, that a thing carries its existence inside itself, independent, self-contained, real on its own terms. The Buddhist word for what he denied is the absence of own being, emptiness, sunyata, and the popular versions of it are almost all wrong. Emptiness does not mean that things are illusions. It does not mean that nothing exists. It means that nothing exists by itself. A thing is what it is only in dependence, on its parts, on its causes, on its conditions, on the mind that distinguishes it, on everything it is not. Take a chariot, Nagarjuna says. Search it for the chariot. It is not the wheels, not the axle, not the frame, not the sum of them, not something apart from them. The chariot is real enough to ride, and nowhere in it is there a chariot that stands on its own. There is only the dependent arising of parts, which we name. Nothing has its own being. This is the absence of own being, and it goes, he insists, all the way down. And here is the teaching that almost every popular account loses, the one that matters most. It is often said that emptiness means all is one, that beneath the many things there is a single, undivided reality, a ground, a cosmic unity, and that this oneness is what is truly real. This is precisely what Nagarjuna denies. Oneness is a position about existence, and he negates it along with all the others. Emptiness is not a hidden unity behind things. It is not a ground, and, this is the sharpest point, the one the lineage guards, emptiness is itself empty. The absence of own being has no own being either. To take emptiness and make it into the real, the absolute, the one, is to commit the very error the whole analysis was meant to cure. Nagarjuna said it plainly. Those for whom emptiness is itself a view, a thing to hold, are incurable. He held no position, not oneness, not nothingness, not mind only. He left the assumption of inherent existence demolished, and he did not replace it with a new absolute to lean on. This is why the school is called the Middle Way, and the name is exact. It runs between two cliffs. On one side, the belief that things truly, independently exist, the cliff of permanence. On the other, the belief that things do not exist at all, the cliff of nihilism, the misreading that hears the word empty and concludes that nothing is there and nothing matters. Nagarjuna refuses both. He does it with a distinction the tradition guards as carefully as emptiness itself, the two truths. There is conventional truth, the level on which the chariot rolls, and the fire burns, and a promise binds. All of it perfectly real, perfectly functional. And there is ultimate truth, the level on which none of it has its own being. The two do not compete. The conventional is not a lie to be discarded. It is how the empty world actually works. Emptiness does not drain the world of its life. It empties it only of the illusion that anything in it stands alone. Set this beside what the physics reached, and the shape is unmistakable. The relational reading of quantum mechanics, the one Carlo Rovelli proposed, says that no system has properties on its own, that a property exists only in relation to another system, and that there is no master fact standing above all the relations, no view from nowhere. Nagarjuna says, no thing has being on its own, that a thing exists only in dependence, and that there is no ground standing beneath all the dependence, not even emptiness itself. The languages are different, the methods are different. One reasons from a paradox of measurement, the other from a paradox of existence. But the architecture is identical, down to the most easily missed detail, that the relation, the dependence, is not itself made into a new foundation. Both refuse the final ground. Physics did not confirm the monk. The monk did not predict the physics. The convergence is structural, and it is exact. What separates them is everything except the structure. Nagarjuna was not solving a problem about photons. He was after the end of suffering. He believed that the mind clings to things as if they had own being, and that this clinging is the root of all anguish, and that seeing through it is freedom. His emptiness is a door out of pain. Rovelli's relations are a way through a contradiction in a theory. Same shape, different universe of purpose. And the image he leaves is the simplest one. A thing is like a reflection in water, fully present, fully functioning. You can see it, point to it, be moved by it, and empty, all the way through, of anything standing on its own. He had another image for it, sharper, fire and its fuel. The fire is not the same as the wood it burns, and it is not different from it either, for there is no fire standing apart, waiting, with no fuel to be the fire of. The fire is neither identical to its fuel, nor separate from it. It arises in dependence, and in that dependence it fully, warmly is. Look for the fire that owns itself, and the hand closes on nothing. Warm your hands at it anyway. That emptiness has a consequence, the same Buddhist lineage drew out, centuries later, into one of the most beautiful pictures any tradition has produced. Because if nothing has its own fixed boundary, if no thing is sealed inside itself, then everything reaches into everything. In 7th century China, a monk named Fazang built a hall of mirrors to show an empress exactly this. He placed a single statue and a lamp at the center of a room lined on every side, above and below, with mirrors, and each mirror held the statue, and held every other mirror's reflection, and held the reflections of the reflections, without end. One thing, everywhere at once, every surface containing the whole. The teaching his school transmitted is the mutual interpenetration of all phenomena, Shishiwai, the non-obstruction of thing, and the image for it is the net of the god Indra, a net stretching infinitely in all directions, with a jewel at every knot, each jewel reflecting every other jewel, and all the reflections reflecting one another, endlessly, with no jewel at the center and none at the edge. The popular version stops at, everything is connected, and that is too small, and it misses the machinery. The point is not that things are linked by some current passing between them. The point is that each thing, precisely in its full particularity, already contains the whole, and the whole is fully present in each thing, because nothing has the sealed, separate boundary that would keep them apart. Emptiness is what makes the interpenetration possible. The absence of own being is the open door through which each thing holds all the others. And the school did not leave this as a single image. It built it into a structure, an ascent through 4 ways of seeing: the world as separate things, then the world as the one emptiness underlying them, then the seamless fitting of that emptiness with each particular thing, and finally, at the summit, the seamless fitting of each thing with every other. That summit, the non-obstruction of thing and thing, is the level the net of Indra portrays. It is the most demanding vision in all of Buddhist philosophy. And it is not the gentle thought that everything is connected. It is the vertiginous one, everything containing everything, and lost in nothing. This is the architecture of a reality, with no privileged center, every node holding every other, the separation we perceive being the surface, and the mutual containment being the depth, which is the shape of a world where the parts are not finally separable, the shape the no-go theorems press toward from the other side. The map is drawn from a different continent. It looks strangely like the territory. The same dissolution of the separate, fixed thing appears in another tradition entirely, in a different key, with a lighter touch. In 4th century BCE China, a man named Zhuangzi told a story about waking. He had dreamed he was a butterfly, drifting and content, knowing nothing of any Shuangzi. Then he woke, and was a man again, and he could not say which was true, whether he was a man who had dreamed he was a butterfly, or was now a butterfly dreaming he was a man. He did not tell the story to be charming. He told it to unfix something. Anyone who has surfaced from a vivid dream and lain still for a moment, unsure for a breath which side of it was the real one, has stood for an instant exactly where Zhuangzi chose to stand on purpose. What he was unfixing is the assumption that there is a single correct standpoint from which things are what they are. In the chapter known as the discussion on making all things equal, Zhuangzi argues that this and that, right and wrong, acceptable and unacceptable, are never simply features of the world. They depend on where one stands. Every this is a that from another position. Every judgment of right carries its wrong folded inside it, waiting for the standpoint to shift. And the sage, he says, does not climb onto one perspective and call it the truth. The sage rests at what he calls the axis of the way, Dao Shu, the pivot or hinge of the Tao, the still center of the turning circle, which belongs to no point on the rim, and from which the endless turning of perspectives can be met, without being trapped in any one. When this and that no longer find their opposite, he writes, that is the pivot of the way, and the pivot, set in the center of the ring, responds without end. Here too, the popular reading flattens it, and the deeper reading was preserved by a specific hand. The flattened version says, Taoism teaches that all is one, that the 10,000 things melt into a single undivided whole. But making things equal does not mean dissolving them into sameness. The commentator Guo Xiang, in the 4th century, drew this out with precision. The equality is an equality of standpoints, not a merger of substances. Each thing is fully, spontaneously, itself. What the tradition calls self-so, ziran, being so of itself, and there is no ruler behind them, no single privileged Tao standing apart as their source. The way is nothing other than the self-so functioning of the things themselves. To equalize is to stop absolutizing any one perspective, not to blur all things into a featureless unity. The opposite, in fact, of all is one, and this is the same architecture once more, from the side of the standpoint, rather than the thing. The relational physics says there is no view from nowhere, no privileged frame from which the facts are simply the facts, the same for all. Zhuangzi says there is no privileged standpoint from which this is simply this. Every this is relative to a position, and the wise response is not to find the true position, but to rest where no position is absolute. The languages differ. The methods differ. One a chain of theorems, the other a story about a butterfly. The structure is the same, a reality in which the standpoint cannot be subtracted, in which there is no outside from which to see it whole. What Zhuangzi was after was not a resolution of physics. It was freedom, the ease of one who wanders through the transformations without being caught by any of them. The image he leaves opens the same chapter. A great wind rises and moves across the earth, and the 10,000 hollows begin to howl and moan and whistle, each according to its own hollow shape, the piping of the earth. And then he asks the question the whole tradition turns on. All these voices, every one of them different, who is it that arouses them? Guoxiang's answer, and Zhuangzi's, is the unsettling one. No one. There is no piper behind the sounds, no single player working the hollows from somewhere outside. There is only the wind and the shapes, sounding themselves. One breath, countless voices, no voice the true one, and no one beneath them all to make it so. The Buddhist turned his attention on the thing and found no thing. The Taoist turned his on the standpoint and found no fixed standpoint. A third tradition turned the same attention on the one who is doing the looking. And this is where the inquiry comes closest to the body of anyone listening in the dark. In India, the shortest of the Upanishads, the Mandukya, took apart the whole of conscious life by following a single thread. The passage every night from waking through dream into deep and dreamless sleep. It is the text the 8th century teacher Shankara, the great systematizer of the school called non-dual, Advaita, treated as containing the essence of everything. The analysis is this. In waking, consciousness faces outward, into the world of solid things. In dream, it faces inward, into a world made entirely of itself, of images with no matter. And in deep sleep, the dreamless kind, the kind with no images at all, something strange happens that the tradition would not let pass. The world is gone, the objects are gone, the dreaming is gone. There is no division into a one who sees and a thing seen. And yet it is not annihilation, because a person returns from it and says, "Truthfully, I slept well. I knew nothing." That sentence is the hinge of the entire teaching. To report that you knew nothing, there must have been something present to register the absence. Some awareness remained, with no object at all to be aware of, present through the very state in which everything else dropped away. The tradition calls it the witness, sakshin, the bare consciousness that does not change, while the three states come and go across it, and it gives that witness a name that is not a fourth thing, but the ground of the other three. It calls it simply the fourth, Turiya. Here the popular version goes badly wrong, and the correction is the whole point. The fourth is constantly described in books on spirituality as a special state to be achieved, a higher experience to be reached through practice, a fourth room beyond the three. The Mandukya says the opposite. The fourth is not a state alongside waking, dream, and sleep. It is the awareness in which all three appear and vanish, the constant in which the changing is known, and it is already and always the case. It is described only by negation, not turned outward, not turned inward, not both, not a mass of consciousness, not knowing, not unknowing, ungraspable, beyond all marks, the very form of fourfold negation that Nagarjuna used. You do not travel to the fourth. You recognize it as what was witnessing all along, and the text's great saying is not, I am the world, and not, I make reality. It is quieter and more exact. This self is the absolute. I am Atma Brahma. The witnessing awareness, stripped of every object, is the same in all, and is the ground of what is. And the tradition's boldest claim sits one layer deeper still. In the commentary the teacher Gaudapada wrote on this same short text, perhaps a century before Shankara, he drew from the analysis a conclusion he called non-origination, ajativada, and it is as radical as anything Nagarjuna wrote. Nothing, he said, was ever truly born. The world of separate things never actually came into being as an independent reality at all. What looks like a world arising is, from the standpoint of the witness, closer to the appearing of a dream within sleep, present, vivid, utterly convincing, and never once becoming a thing that stands on its own outside the awareness in which it shows. It is the furthest reach of the teaching, and the lineage transmits it quietly, because it is so easily mistaken for a denial of the world. It is not that. It is a denial that the world was ever separate from the awareness that knows it. This does not parallel the physics in the way the others do, and the difference must be stated honestly, because the temptation to overstate it is enormous. Physics did not discover that consciousness is the foundation of reality. Nothing in the no-go theorems says the witness is the quantum substrate. To claim that would be exactly the manifestation fantasy this whole inquiry has refused. The parallel is structural and narrower. Physics arrived at a reality whose facts are frame-dependent, true relative to one system, otherwise relative to another, and was left with the question of what, if anything, holds across the frames. The Mandukya took the most radical frames available to a human being, the waking world and the dream world, and the worldless dark of deep sleep, each one a completely different reality, and asked what does not change as the worlds change. Same structural question, asked of experience instead of measurement. And its answer, that what is invariant is not any world but the bare witnessing in which the worlds arise, is a possibility about the structure, not a proof of one. The languages are different, the methods are different. The territory each is mapping may not even be the same territory, but the maps rhyme. And the image the tradition leaves is one the body already knows, because it visits it without fail every night. The dreamless dark, where the world is set down, and something remains that will say, in the morning, that it was there. The same structure, reached by yet another road, lies at the center of a tradition that grew in the deserts of a different faith. In 13th century Spain, in Andalusia, a Sufi master named Ibn Arabi, whom his followers called simply the greatest master, taught something so dangerous that the Orthodox tradition spent the next 6 centuries trying to sanitize, condemn, or contain it. The doctrine came to be called the unity of being, though that phrase was sharpened into a slogan by his students, not by him. And its real depth is not in the slogan. It is in a single, easily misunderstood idea, the imaginal, and the isthmus that he placed at the heart of reality. The idea is this: there is one reality, which he calls the real, and everything that exists is its self-disclosure, the real showing itself, taking form. But the real never shows itself the same way twice, and never shows itself whole. Each thing, each knower, receives the real according to its own capacity, its own readiness, the shape of its own particular receptacle. And so, every knower's reality is a genuine disclosure of the one real, and a partial one, formed by the receiver, and different from every other. Ibn Arabi, pushed this to a conclusion that frightened the jurists. Each believer, he said, worships the God created in their own belief. Not a false God, but a true and partial disclosure, shaped by the limits of the one who receives it. The one who truly knows does not confine the real to a single form, but recognizes it in every form belief takes, and reduces it to none of them. The perspectives are real. They are irreducibly many. None of them is the whole, and all of them are the one real, disclosing itself through the only thing it can ever appear through, a particular point of view. The hidden content, the thing the popular accounts miss entirely, is the status of the in-between. Ibn Arabi's word is the isthmus, barzakh, a barrier that joins, a boundary that is also a passage, a reality that stands between two others and partakes of both while being neither. The imaginal world is such an isthmus, not the world of pure spirit and not the world of solid matter, but a real domain between them, where meanings take on form and forms become transparent. And here is the correction that matters. This is not imagination in the sense of fancy or mental invention. The popular reading treats Ibn Arabi's imaginal as a poetic name for daydream, for the made-up. It is the opposite. For him, the imaginal is an ontological reality, a real intermediate world with its own laws, more real than matter, not less. The place where visions and dreams and the forms of the unseen actually are. The whole structure of his thought turns on the isthmus, on the in-between that both separates and joins. And his unity of being is not the simple claim that God is the world, which would collapse the distinction. It is the far subtler holding together of transcendence and immanence at once, the real, both utterly beyond every form and intimately present in each, refusing to be either merged with the world or severed from it. The barzakh is that refusal made into a principle. It is worth seeing why this was so dangerous, because the history is instructive. To a certain kind of jurist, the teaching sounded like the erasure of the line between God and creation, like the claim that the world simply is God, which orthodox theology could not allow. A century after Ibn Arabi's death, the great Hanbali jurist Ibn Taymiyyah attacked the unity of being as something close to heresy, and the attack never entirely stopped. Later masters offered a softer substitute, the unity of witnessing in place of the unity of being, the idea that the mystic experiences all things as one, without that oneness being literally true of reality, which let the line between creator and creation be drawn again, and the orthodox conscience rest. And the imaginal fared no better. For centuries it was quietly demoted into mere metaphor. The imaginal collapsed into the imaginary, until a scholar of the last century, Henry Corbin, had to coin a new term in Latin, the imaginal world, mundus imaginalis, simply to force the distinction back into view and stop a real domain from being read as a fantasy. The teaching was too precise to destroy and too dangerous to leave standing, so it was sanded down again and again for 600 years. The parallel to the physics is the most precise of all of them. The relational reading says, every observer's reality is genuine. None is privileged. All are facts relative to a system, and there is no master fact, no description from outside all relations, in which the world is finally what it is for everyone at once. Ibn Arabi says every knower's disclosure is genuine. None is privileged. All are the real relative to a receiver, and there is no form in which the real appears the same to all, no disclosure from outside all perspectives in which it is finally seen whole. A single ground, appearing only ever through points of view, never in itself to any finite knower, every view real and none of them total. That is, structurally. the picture the theorems left standing, and the isthmus, the boundary that is also a relation, is the very shape of the cut between observers, the line that both divides their worlds and binds them. Physics did not validate the mystic did not predict the physics. The real is not the quantum vacuum, and self-disclosure is not decoherence, and a theorem is not a vision. The structure is shared. The content could not differ more. And the image he leaves is the one his own scripture gave him, the place where two seas meet, the fresh and the salt, flowing together and yet held apart, with a barrier between them that neither crosses, the isthmus, where the one water is two, and the two are one, and the boundary itself is the most real thing of all. 5 investigations, 5 methods that share almost nothing, a dialectic that dismantles every position, a hall of mirrors, a story about a butterfly, the analysis of dreamless sleep, the self-disclosure of the real to the heart of the knower. They were undertaken on different continents, in different centuries, in service of different ultimate aims, the end of suffering, the freedom of the wanderer, the knowledge of the self, the knowledge of God, and they converge on a single architecture, no thing standing alone, sealed in its own being, separateness as the surface, and dependence, relation, perspective as the depth, and no privileged place outside it all, no final ground, no true standpoint, no view from nowhere, from which the whole would resolve into a single settled fact. This is not coincidence, and it is not proof. It would be a failure of nerve to call it either. It is not coincidence, because too many independent inquiries, held with too much rigor, have come to rest in the same shape for chance to be a satisfying account. And it is not proof, because structural resemblance is not demonstration, and a map that rhymes with another map has shown you nothing about the territory until you ask, carefully, what such a rhyme could mean. The traditions did not run the experiments. The physics cannot reach the questions the traditions were really asking. What stands when the overclaiming is stripped away and the dismissal is stripped away with it is a recognition that the most rigorous edge of the most exact science and the deepest reports of the oldest contemplative disciplines describe a reality of the same shape, by roads that never crossed. It is the kind of fact that does not fit the shelves we keep. It is not a result, because nothing was measured. It is not a doctrine, because no one is asking for belief. It is not even, quite, a discovery, because every piece of it was already old. It is the strange quiet that falls when two voices that could not possibly have heard each other are found to be saying, in their own tongues, the same impossible thing. And the only honest thing left to do with a recognition like that is to ask, plainly and without comfort, what it is and is not allowed to mean. So what is it allowed to mean? Not for physics. What it means for physics is, by now, almost clear. 100 years of one open question, sharpened in the last decade to a single edge, with no agreement anywhere on the horizon. The harder question is the one underneath the equations, the one they were always finally about. What it is for anything to be, what being is, what this is. And the honest answer begins not with a conclusion, but with a kind of standing. None of what has come before has produced a verdict. It has cleared a piece of ground, and the work now is to stand on that ground without flinching in either of the two directions. Almost everyone flinches in, the direction that claims too much, and the direction that dismisses too fast. The popular mind wants the result to mean everything. The hardened mind wants it to mean nothing. Both are running from the same difficulty, which is that the truth here is narrow and exact and does not comfort. There is a particular discipline in refusing both flinches at once. It is easy to be a believer, It is easy to be a debunker. Each is a way of being done with the question, of setting it down and walking off relieved. The harder thing, and the only honest thing, is to keep holding it, to say exactly how much weight the evidence will bear, and not 1 ounce more, and to keep standing there after the saying is done. So it is worth saying slowly what has actually been shown, and then, with the same care, what has not. What is established is this: quantum mechanics is the most precisely tested theory in the history of science, and nothing in a century of experiment has ever caught it in an error. That is not in doubt. It will not be overturned. Whatever the world finally turns out to be, it behaves, to as many decimal places as anyone can measure, exactly as this theory says it will. What is established is that the world is not both local and separable in the way ordinary intuition demands. In 1964, John Bell had turned Einstein's old objection into something a laboratory could finally decide, and the laboratories decided. By 2015, the last loopholes were closed. In 2022, the work was given the Nobel Prize. The result is not subtle, and it is not in dispute. The universe does not permit every part to carry its own separate, local store of properties, fixed in advance, independent of all the rest. That door is shut. It is one of the very few things in this entire story that is simply, flatly known. What is established is that the theorems are proofs. The result from Zurich, that quantum theory, cannot consistently describe agents who are themselves using it, is not a speculation and not an interpretation. It is a proof, and it stands. The stronger theorem from Brisbane, built from premises more basic than quantum theory itself, is a proof, and it stands. Together they show, with the finality that belongs only to mathematics, that you cannot keep all of the ordinary assumptions about a single shared world at the same time. One of them is false. That much is certain. Which one is false? That is another matter entirely. And what is established is that the experiments were run. Particles of light were made to stand in the place of observers, and the limit that any observer-independent world would have to respect was broken. On a table, in a laboratory, more than once. That happened. It is a fact about the world, confirmed and repeated. And what is established, finally, is the reason the world looks as solid and as single as it does. The constant, unrelenting touch of the surroundings on every system, air, light, warmth, washing the strangeness out of reach faster than any eye could ever catch it. That mechanism is real. It is measured. It explains, with precision, why no one has ever seen a cup of coffee resting in 2 places at once. What it does not explain, and this was always the honest limit of it, is why there comes to be a single cup at all. But that the mechanism is real, no one disputes. This is the bedrock, the mathematics, the proofs, the measured violations. None of it is going away. Anyone who tells you the strangeness is a misunderstanding, a confusion of bad philosophy that sharper physics will tidy up, has not read the results. The strangeness is in the data. It has been there for 60 years, and it has only grown sharper with looking. This is the floor, and it holds, and everything else in this account is built on it. Keep it underfoot through what follows. When the talk turns to suggestion, and then to the unknown, it can begin to feel as though the ground itself has gone soft, as though nothing is known at all. That is not the situation. A great deal is known. It is known with a certainty that very few things in human life ever reach. What is not known is what it means. Those are different things, and holding them apart is the entire task. What is suggested is something larger and softer, and it has to be marked clearly as suggestion, because the line between what the evidence proves and what it merely leans toward is the same line that separates honesty from everything else. What is suggested is that the false assumption, the one that has to give, may be the one we would least like to lose. The assumption that there is a single shared world, that beneath every observer there lies one set of facts, the same from every side, belonging to no one and binding upon all. The most natural reading of the results, the one that asks for the least contortion, is that this is the assumption that fails, that a fact may be real only in relation to a system, that there may be no view from nowhere, no master account from outside all standpoints, in which the world is finally just what it is. This is the relational reading. The evidence leans toward it. Leans. It does not compel, because there is another reading, held by serious people, and it keeps the single objective world at a different and enormous cost, the cost of an unobservable infinity of branching worlds, and a notion of probability that no one can quite make sense of. That picture reads the same proofs and the same violations and surrenders, not the shared world, but the single outcome. It is not absurd, it has not been refuted, and as long as it stands there, coherent and unkillable, the relational reading remains a suggestion, and not a deduction. It is worth being clear about why this matters so much to get right. The relational shape and the branching shape are not small variants of a single view. They are opposite resolutions of the same crisis. One keeps the single world and multiplies the outcomes. The other keeps the single outcome and lets the single world dissolve into a web of relations. They cannot both be the last word, and the evidence, as it stands, does not choose between them. To announce that the physics has shown reality to be relational, or shown it to be one vast branching whole, is to mistake a living argument for a finished one. So what is suggested is a shape, a reality in which separateness is the surface and relation is the depth, in which the clean line between this and that, between the one who observes and the thing observed, between one world and another, is not the ground floor of things, but a feature of the view from where we happen to stand. The evidence makes this shape more plausible than it has ever been before. It does not hand it over as proven. That difference matters more than almost anything else in this account, and it is exactly the difference the popular versions erase. To say that a thing is suggested is to say the world has been caught leaning. It is to report a pressure, a tilt in the evidence, a direction the data points when it is allowed to point freely. It is not to report an arrival. The popular telling cannot abide that distinction, because a lean is not a headline, and a tilt cannot be sold. But the whole of honesty lives in the gap between leaning and arriving, and anyone who cannot feel that gap cannot be trusted to tell you what the world is like. And then there is what remains unknown, which is the largest country of all, and the one this whole inquiry has been circling from the beginning. What remains unknown is the measurement problem itself. Why, out of the cloud of every possibility, one single fact appears? What happens, if anything happens at all, in the passage from the many to the one? That question opened in 1926, and it is open tonight, and the three results of the last decade have not closed it. They have made it sharper and harder to escape. They have not answered it. After 100 years of the most exact science human beings have ever built, no one knows why. When you look, you see one thing and not the others. It is the simplest question a child could put to the theory. It is the one question the theory cannot answer. 100 years of unbroken success, and at the very center of it, a silence. What remains unknown is what an observer even is. The experiments used particles of light. Whether a particle of light is an observer in any sense that reaches all the way up to a human being, no one knows. The whole strange structure has been shown to fail at the level of light, where it is cleanest to test. And the distance from a particle of light to a person who wakes and remembers and calls themselves a witness is a distance no experiment has yet crossed. It may be that the result climbs all the way up, and that two human beings really can hold facts that cannot be reconciled. It may be that something changes on the way up that no one has yet found. We do not know, and this is not the not knowing of a measurement still to be made, which time and patience will fill in. It is the other kind, the kind that sits inside the structure and does not move when more data arrives. And folded inside that unknown is the oldest temptation of all, which honesty requires naming and then setting down. It is tempting, when the structure fails at the level of light and the word observer will not sit still, to reach for consciousness, to say that mind is the missing ingredient, the thing that makes the one fact out of the many. This whole account has refused that reaching from its first minute, and refuses it still, because nothing in any result requires it, and a particle of light is no one's idea of a mind. But the honest form of the refusal is not a flat denial. It is an admission. We do not know what an observer is, and so we cannot say, with the certainty the debunker would prefer, that awareness has nothing whatever to do with it. We can only say that nothing has ever shown that it does. The question of what counts as a witness is open. It is not open in the direction the manifestation peddlers want it open. It is simply, genuinely open. What remains unknown is which of the maps, if any of them, is the territory. After a century, not one of the interpretations has won the assent of those who study them. The relational reading, the many worlds reading, the theories that change the equation to make the collapse real, the readings that place the whole description inside the mind of the agent. Each one survives, each one pays its own price, and none has prevailed. This is not a passing confusion that the next clever experiment will settle. Some of these pictures make precisely the same predictions as the others, and will go on doing so forever. They cannot be told apart by any measurement, not even in principle. The choice between them, if there is a choice to be made, is not the kind of choice that data can make. This is a strange and specific kind of ignorance, and it is worth dwelling on, because it is not the ignorance that science usually faces. Usually the unknown is a gap that better instruments will close, a faint signal, a distant object, a number measured to too few places. This is not that. Here the instruments are not the problem. A person could know every measurable fact about the world, every outcome of every possible experiment, to perfect precision, forever, and still not know which of these pictures is the true one, because the pictures agree on every measurable fact and part company only beneath them, in a region no measurement reaches. The unknown is not at the edge of our seeing. It is woven into the scene, and what remains unknown, underneath all of these, is whether the question even has the shape we keep assuming it has. We go on asking what reality is really doing when no one is looking. It is possible, and this is one of the things the relational reading quietly proposes, that the question has no answer because it is not a good question, that there is no fact about what the world is doing from nowhere, because nowhere is not a place and never was. If that is so, then the deepest thing this whole inquiry has found is not a hidden answer, but the slow dissolving of the question that demanded one. And whether that is wisdom or whether it is evasion, no one can yet say. The honest position is the one almost no one wants, because it is the least dramatic and the most demanding of all. We do not know. The mathematics works, the proofs hold, the shape is suggestive, and what reality is, underneath, that remains genuinely, structurally open. Anyone who tells you it has been settled, in either direction, by the physics or by the traditions, is selling something. That sentence is the whole of it, and it is worth carrying out of here intact. Not because uncertainty is a comfortable place to rest, it is not, but because it is true, and because the two alternatives on offer are both lies, and the more attractive lie is not 1 ounce less of a lie for being the more attractive. And the convergence, the strange rhyme between the far edge of the physics and the oldest reports of the contemplatives, has to be held to this very same standard, which means holding it with both hands open. The hardened skeptic has a case, and it deserves to be stated at its full strength. The mind is a pattern-finding engine, hungry for resemblance, and the phrase "no thing stands alone" is loose enough that a great many maps would seem to rhyme with it, if a person wanted them to. The contemplatives ran no experiments. The structure they describe was reached with no controls, no measurement, none of the machinery that lets a person tell insight apart from projection. And the physics, the skeptic says, will most likely find a perfectly ordinary resolution in the end. A collapse mechanism, perhaps, or simply the many worlds. And when it does, the mystical parallel will look like what it most likely is, a coincidence of vague language that we wrapped in meaning because meaning is the thing we crave. This is a serious objection. It is not wrong to feel its weight. And there is an objection from the other side, just as serious. The strict contemplative would say that the physics is beside the point, that the traditions were never describing the behavior of particles at all, that they were pointing toward liberation, toward the real, toward the witness in dreamless sleep, and that to drag a theorem in as confirmation is to misunderstand them at the root and to make them smaller. To turn the monk who dismantled every position into a footnote to a physics paper is to lose him entirely. The emptiness he taught was a door out of suffering, not a description of measurement. To read it as physics is its own kind of category mistake, made from the opposite direction. Both objections are right, and the open ground lies between them, and the whole discipline is to stand there and not topple toward either wall. Notice that the two objections do not cancel each other out. They are not a debate with a winner waiting at the end. They are two true things, said from two different places, and the ground between them is not a compromise but a third place, harder to stand in than either, the place where the resemblance is granted its full strangeness and denied its false authority in the same breath. The convergence is real as structure and silent as proof. The relational reading is not the claim that mind makes matter. Emptiness is not a wave function. The isthmus between the worlds is not a space of mathematics, and the witness in deep sleep is not the collapse of a state. Nothing here proves anything about anything. What is true is only this: that two ways of investigating what is, sharing no method, no aim, no single word of vocabulary, came by their separate roads to a reality with the same architecture. That is not a proof. It was never going to be a proof. It is a recognition, and a recognition asks nothing of anyone, except that they not look away from it. Because you have stood at this edge yourself, not in a laboratory and not in a monastery, in the ordinary places. You have had the moment when something arrived too precisely to be chance, and you could not quite call it meaningless, and could not quite call it a message, and you let it pass, without deciding either way. You have looked up, on some clear night, into the depth of it, and felt yourself go small, in a way that was not unpleasant, felt, for one moment, the sheer fact that there is anything at all rather than nothing. You have recognized something, once or twice in a life, that you could not afterward explain, and could not argue another person into, and that did not go away for being unprovable. These moments prove nothing. That is not their work, and it would be dishonest to pretend otherwise. But they are not nothing either. They are the places where an ordinary life stands, without trying and without training, at the same edge where the physicist and the contemplative spent their decades on purpose. The edge where the separate world goes thin, and something shows through it, and the mind falls quiet, because it has met the limit of what it can hold. These are not large events. They do not announce themselves. They arrive in the middle of an ordinary day, and are usually gone before they can be turned over and examined, filed away afterward under coincidence, or tiredness, or a trick of the light. But something in a person keeps them. Years later, they are still there, unargued and unexplained, a small, private collection of moments when the floor of the obvious thinned to glass, and something vast moved underneath it. And there is one of these places you go every single night, without effort, without belief, without fail. Each night you lie down, and the world you were so certain of softens at its edges, and the day's solid facts loosen their grip, and you cross over into the dreaming, where a whole world is built out of nothing, and feels, while you are in it, complete. And then past even that, down into the dark with no dreams in it at all, the dreamless dark, where there is no world and no one set apart from a world, and no boundary anywhere between a seer and a thing seen. The oldest of the texts called it the deepest of the states, and the nearest to the ground. Everything you take yourself to be is laid down there, and something remains, because in the morning you come back, and the world gathers itself around you again, and you know, without anyone telling you, that you were there. You have already been to the place where the one who observes dissolves. More times than you could ever begin to count. You go there again tonight. And you have never once been afraid of it. This is the thing worth pausing on. The dissolving of the separate self, which sounds, described in the daylight, like the most frightening idea there is the very thing you have longed for at the end of every hard day, the relief you sink into gratefully, the one untroubled country still left to you. You do not dread the place where you disappear. You wait for it. You are waiting for it now. So the question, that the most exact science could in the end only point toward, and the question that the oldest silences were built around, is not a far-off thing, kept in laboratories and caves. It is the most familiar thing there is. It is what happens to you in the passage from one day into the next. The dissolving of the separate world is not a theory to be believed, and not a state to be achieved. It is the ground you are lowered onto every night, and lifted back out of every morning, and have never once been able to remember from the inside, because there is no one inside it left to remember, and you return from it unharmed. That is the quiet astonishment the analysis keeps circling, and the night keeps quietly performing. Every morning the separate world is handed back, whole, the cup on the table, the light at the window, the name you go by, all of it gathered up again as though it had never once come apart. The dissolution is not an ending. It is the thing that happens, gently, in the space between the days. It has happened every night of your life. It will happen tonight. And it asks nothing of you, but that you lie down. There is no view from nowhere. There never was. There is only this. What is here, met from where you are, real and partial, and yours, with no place to stand outside it all, and take in the whole at once. And that is not a loss. It was only ever called a loss by those who wanted to stand nowhere and see everything. No one has ever stood there, and the friend is still in the room, certain of something no one outside can confirm, the way you are certain now of being here, while the world goes on not quite agreeing, and the dark settles, and the question stays open where it has always been.